You are not going to achieve weight loss if you rely only on exercise. It's a poor method. It's good for other things, multiple things. But when it comes to losing weight or keeping a low body fat, exercise is not the best way to go. The main determinant from what we learned is the food that you eat and the choices that you make. And that's why, for us to be able to break away from this original idea and try to approach the problem in a different way, we need to understand this. So the short-term signals, they inform specific centers in your brain about the size of the meal and the timing of the meal. No matter how you were going to calculate this, if you're going to use calories or if you're going to use weight of food, whatever, one thing we know, if you want to lose weight, you cannot eat a lot. You have to reduce how much you eat. You have to contain, you have to be able to limit how much you eat to the point that you feed your body, you're nourished properly, but you're not going beyond what is necessary. And this is, I think, the critical factor that plays a role here. And this is all related to this communication between your gut and your brain. There are two hormones. One of them is called ghrelin. The other one is called cholecystokinin. They send short-term signals from the gut that regulate food intake on a meal-to-meal basis. In other words, between breakfast, lunch, and dinner, or whatever you do in between. So ghrelin is released during the post-absorptive state or under fasting conditions, and it's a hunger signal. If you were to measure when you wake up in the morning, assuming that you have not eaten anything overnight, and you measure in your blood ghrelin, you're going to see that it goes up. It creeps up progressively. So ghrelin comes up before you eat, goes down after you eat. Then if you have an interval of time between one meal and another, ghrelin goes up again to the point that you're going to have another meal. Then it goes down, stays down for a while, goes up, and you have another meal. So the number of meals or the frequency of your eating has a lot to do with these cycles that ghrelin determines. Now, on the opposite side of ghrelin, we have CCK, that is cholecystokinin. This one is released as you eat, during the meal. So when you're eating, ghrelin is being suppressed, CCK goes up. CCK acts through the vagus nerve. There is a difference between ghrelin, because ghrelin is released by the stomach into your bloodstream and goes to your brain. And your hypothalamus senses it and stimulates hunger. Now, when you eat, CCK acts or signals through the vagus nerve and sends directly information to your brain, again, to your hypothalamus, to signal satiety. That's what makes you look at the food and say, I don't want to eat anymore. That's not leptin, because leptin is still, you had almost no change in leptin at all, because your adipose tissue didn't change yet. What made the difference between one meal and another was the signals that are constantly acting as short-term. So we have these two arms, CCK, ghrelin, and CCK. Ghrelin is unique because it's the only known circulating hormone that strongly increases hunger. CCK is short-acting. It mainly controls meal size, not long-term body weight. It's controlling how much you're eating every meal. Now, if you overeat chronically, then this ghrelin rhythm can be blunted because you're constantly eating, so you don't have like an empty stomach to the point that you're going to release ghrelin. So you blunt the ghrelin. But the problem is that when you overeat, you end up developing what they call satiety resistance. You increase CCK but your body does not respond to CCK as much. What's the implication of this? Some people have this idea that the best way for you to fight hunger is to eat every 2 hours or every short period. So you eat many, 5, 6 meals a day. So it can be detrimental in some aspects, because if you keep your stomach full all the time, you don't have the cycles, but you also reduce the sensitivity to CCK. So you don't become as satiated all the time, or through a prolonged period of time. So in other words, you end up developing what they call satiety resistance. So this is another important aspect, because again, we want to be able to control how much we eat without being a slave of food all the time. So now, if you look at ghrelin, as I said, it's produced by the stomach and travels in the bloodstream to the brain, especially in the hypothalamus, where it activates neurons in the arcuate nucleus. Remember the NPY that I mentioned before? Called agouti-related protein. So these are neurons that respond to NPY. So they increase food intake, promote hunger, food-seeking behavior. You really want to find food. And also it increases gastric mobility or stomach growling. So when you are long-term, if you fast long and your stomach starts growling, that symptom is because ghrelin is being released and promotes motility in your stomach. And that causes the growling. So it's a typical signal your ghrelin is up. And obviously you're hungry, and that forces you, or kind of drives you to seek food. That's why it's called food-seeking behavior, because it really drives you towards that. Now, CCK is released from the eye cells in the duodenum and jejunum. So you see how these are two different parts of your digestive system? Ghrelin is in the stomach. It's in the upper portion of your GI tract. CCK is in the eye cells that are localized in the duodenum and jejunum. So it's in the lower portion or mid portion of your GI tract. So it activates CCK-A receptors on vagal, afferent nerves. So you have nerves that are innervating your small intestine. So once CCK is released, it senses it, gets the signal, and goes to your brainstem. There is an area called NTS, or nucleus tractus solitarius, which is an area that actually also controls what's going on or influences your hypothalamus. So indirectly influences hypothalamic centers to suppress feeding. So it shuts down that NPY system, so you eat less, so you feel less hungry. It also does another thing. It slows gastric emptying and prolongs fullness. Remember, ghrelin promotes motility. So accelerates whatever is kind of moving things fast, but there's nothing there, so you get the growling feeling. Now CCK does the opposite, because it slows gastric emptying and makes you feel full longer. And also stimulates pancreatic enzyme secretion and gallbladder contraction. So you learned this because we did digestion, and we know pancreatic enzyme secretion is for you to be able to digest fat, protein, and carbohydrate. Gallbladder contraction is to release bile, which is also important for metabolism of fat. By slowing down gastric emptying, it also allows more time for these enzymes to act and for the nutrients to be absorbed. So that's why you feel also fuller or longer, or the fullness feeling is extended. So that keeps you full longer.